Given the hyperbola with the coordinate axis, by letting the difference between the two lengths PF1 and PF2 to be 2a, we will derive the equation for the hyperbola. First, we need to find the length PF1 and PF2, where we will use a distance formula. To avoid working with the square root, we will find the distance square for now. The distance square of PF1 is the change in x. F1 is the focus on the left and F2 is the focus on the right. The distance PF1 is therefore x minus negative c. This is the change in x squared plus the change in y minus 0 squared. And so we have x plus c, the quantity squared, plus y squared. The distance PF2 squared is similarly x minus c, the difference in x squared, plus y minus 0 squared. And this is simply x minus c squared plus y squared. Regardless of where the point P is, on the left or on the right hand side, the difference between the two lengths is 2a. So if we take the distance PF1 minus the distance PF2, then we'll end up with plus or minus 2a. If PF1 is greater than PF2, then we'll end up with 2a. Or if PF1 is shorter than PF2, then we'll end up with negative 2a. The distance PF1 is the square root of x plus c squared plus y squared, minus the distance PF2 is the square root of x minus c squared plus y squared, equals plus or minus 2a. To simplify this expression, we would need to isolate one term with the radical, and so we will keep the square root of x plus c squared plus y squared equals plus or minus 2a plus the square root of x minus c squared plus y squared. We then square both sides of this equation. The left-hand side is x plus c squared plus y squared, where the square root and the square cancelled out. The right-hand side is now plus or minus 2a squared minus or plus 2 times 2a times the square root of x minus c squared plus y squared, plus, and the last term squared, which is x minus c squared plus y squared, because the square root and the squared cancelled out. We then distribute x squared plus 2xc plus c squared plus y squared equals 4a squared. This is still plus or minus 4a, the square root of x minus c squared plus y squared, plus x squared minus 2xc plus c squared plus y squared. The y squared on the left and the y squared on the right cancelled out. X squared on the left and x squared on the right cancelled out. C squared on the left and c squared on the right cancelled out as well. We end up with 4xc, where we move the negative 2xc to the left, equals 4a squared plus or minus 4a times the square root of x minus c squared plus y squared. We then divide by both sides of the equation by 4 to obtain xc equals a squared plus or minus a, the square root of x minus c squared plus y squared. And then we keep the term with the radical on one side. This is now xc minus a squared equals plus or minus a, the square root of x minus c squared plus y squared. We then square both sides of the equation to get the left-hand side is now xc squared minus 2xc times a squared plus a to the fourth, and the right-hand side is a squared times the quantity x minus c squared plus y squared. This is now x squared c squared minus 2xc a squared plus a to the fourth equals a squared. Distribute, we have x squared minus 2xc plus c squared plus y squared. Then we distribute a squared on the right hand side. The left hand side is still x squared c squared minus 2xc a squared plus a to the fourth, and the right hand side is a squared x squared minus 2a squared xc plus a squared c squared plus a squared y squared. We see that we can cancel out 2xca squared because they're both negative and they're both on both sides of the equation. We then move the terms with x squared and y squared to the left. We keep x squared c squared, and then we move a squared x squared to the left and a squared y squared to the left. The right hand side is a squared c squared, and we move a to the fourth to the right. To factor out x squared, we have c squared minus a squared times x squared minus a squared y squared equals, factor out a squared, we have c squared minus a squared. At this point, if c is necessarily greater than a, we let c squared minus a squared be b squared. Then we rewrite these equations as b squared x squared minus a squared y squared equals a squared b squared. We then divide by both sides of this equation by a squared b squared. The right hand side is now 1. The left hand side is b squared x squared over a squared b squared minus a squared y squared over a squared b squared. This simplifies to x squared over a squared minus y squared over b squared equals 1. And this is the equation of the ellipse that we need to derive. For this to work, we would need to have b squared equals c squared minus a squared, or simply put, c squared equals a squared plus b squared.